fashion. However, Postgres and Microsoft SQL would actually give you a different set of results. I mean, same set of results, but in different order. Okay, so finally, given that particular table that we have here, customer name and loan number, we need to count the number of loans. So what we do? We just basically group by the customer name and then count on the number of loans, right? So essentially that is what we do. So we need to count the number of accounts for each customer. We would perform a grouping and aggregation operation on this. Remember that grouping and aggregation operations are performed after the results from the from clause, right? So we need to remember that. So after we get the join result, grouping and aggregation is performed on top of that. So then we just have to perform our count operations. So, well, we have two possible cases, possible scenarios, right? One is we can say count star from that result. The other would be count loan number. So in this particular table, can you tell me, and I'm going to ask you guys this question, can you tell me what would be the result? So let's say that this is the only table that we get, forget about the extra results that we might have gotten. Let's say that this is the result, right? If I performed count star, what would be, and group on customer name, but all customers here seem to be unique. So if I say count star, can you tell me what is the result of this thing? So if I say count star, how many counts would I get? 6. Jorge and Leon, could you tell me why? And does everyone agree that Jorge and Leon is correct? Are correct. Exactly, right? So count star essentially counts the number of rows in that table. But if we perform a count loan number, then essentially it is counting the number of loans that the person has. So this is where we need to figure out when we are designing a query as to what we want. Do we want the count star? That just gives us the total number of customers in that table, right? Or the total number of customers in my entire branch. If I perform a count loan number, then that gets me the total number of unique loan numbers that we have in that entire thing, the total number of loans that we have, right? So it is what we want. So essentially count loan number. Notice that we performed a count on loan number here. And I also ordered by the count of loan number at the very end, just to make the results a bit more nicer. And I use that descending keyword to make sure that those are ordered in the descending order. So I can say that Smith has 3 loans, Jackson has 1 loan, and Lindsay has 0 loans, and Brooks has 0 loans, no loans, right? Because those users just had null values. Okay, any questions so far about this? Do you get the on clause? Do you get the different join operations? And are you able to map that from our relational algebra classes to this particular join operations here? Okay. Okay, so so far we talked about the logical level of SQL. So essentially, when we perform queries, we were actually performing our queries on actual relations, right? I mean, actual tables that we have, and we were performing operations on that. But we also talked about derived relations, where we looked at multiple joins or joins and from of multiple tables and got a result from there. And we also talked about nested queries and nested subqueries. I think that for homework 2 as well, you will be able to play around a lot with nested queries and nested subqueries and work on those. So SQL also provides another abstraction on top of your logical level that is directly working with those tables. It also provides another logical level, that is the view level of operation. So this is one more abstraction on top of your logical level. So a view is just in simplest terms the result of a particular query that you can actually interact with in terms of as a table, as a separate table. So all of these query operations generate a table, right? Some table values from those query operations. And I can say that this is basically a view. I'm going to name this as a particular view. This is not a table on its own, but this table is basically the result of performing this operation here. Right, so that is what a view is. So why do we need views is fairly simple, because you can imagine that you have this large set of tables in a database, and that set of tables can have multiple tables and can have multiple relations among them. But let's say that I am just an accountant at a bank, and I don't actually want to, and I don't know how to write the code to actually get the results that I am interested in, right? If I just want the number of loans a customer has, or if I just want if a customer is back on some payment, I really don't want to write that entire query again and again, right? So in that scenario, you as a developer can design a view such that with that particular accountant or me, I can actually look at that view and get the results from there. So essentially, it is more for convenience, and rather than me writing that code again and again, I can actually check that particular view. So this is basically a derived relation, right? So a view is a derived relation where we get the results from combining multiple tables, maybe performing some queries on it and things like that. And whenever we run that view, so if I run a simple query against that view, so let's say that get me all the rows from this particular view, and that is the same thing as select star from this particular view, right? So when I write a query like that, our database system would actually compute the view's contents where the view is defined in terms of a query internally. Some databases also provide us the ability to have materialized views. A materialized view is something where your data is pre-computed and stored on disk. So it is also kept up to date. So if you make some changes to your tables, those stored values are also updated, but this also allows us to access those contents much faster. So if you imagine that we have a really complicated query over a trillion long table, then we really do not want to recompute all of those things. It is better to pre-compute those things and store that in a disk. So we will talk about materialized views. I think assignment 4 actually plays around with materialized views quite a bit. Okay. The other reason for using views would be for security reasons, right? So if I have an entire table of usernames, let's take the bank table again, right? So we can have the salary info, the social security number, other private information of a particular person. We really don't want to expose all of that to someone who is just using that particular database to maybe check if the salary is there or not, or maybe something like that. We really do not want to expose our social security numbers or our taxpayer ID numbers and all of those things to that particular person. So view actually allows us to abstract out security or sensitive information away from users who do not need access to those things. Okay. So how do I create a view? So the syntax for creating a view is pretty simple. You just say create view, view name, as, and whatever statement that you want to execute for that particular thing. So essentially, this is a full-fledged select operation that might include joins and from clauses and all of those things all together, where clauses, all of those things. And we can just say, you know what, this entire query is going to be called this particular view name. And we can create view names with their own attributes as well. And we can also drop a view just by doing drop view name. Okay. So for Angelina, very good question. We would talk about whether a view is read-only or not in just a second. But on that note, do you guys, so let me just talk about this and I'll come back to your question. Very good question. So Angelina is asking whether a view is read-only or not. Well, it seems to be, right? It looks like it should be. Okay, so let's say that we have this select statement that gives you the balance of a particular customer, the total balance of of a particular customer. So select customer name, sum balance as total balance from depositor natural join account, group by customer name, and that gives me the total balance for a particular customer, right? And I can just say that this particular query is now a view called customer deposits. And I can say create view customer deposits as, and that's entire select query. And essentially that gets us our view. And now we can access this entire query by just accessing the customer deposits table. So I can then say, so then I can just say, like, for example, so let's say that I created my view like this. Let me copy over this thing. So let's say I created my view like this. That is essentially select view customer deposits as customer name, sum balance from this depositor natural join account group by customer name, right? And then I can just say select star from customer deposits. And this would basically think of customer deposits as a table, but remember, this is not a table. This is just a temporary query on a view. So we are basically performing a query on a view where whenever we encounter this view, this entire internal query is executed to get you those results, right? So this would give me the total set of customer names every time I execute. So this is a simpler way of writing this, but in general, whenever we, so sometimes, so in general, when, how do I phrase this correctly? So students usually end up start up using views by assuming that these are sort of temporary tables so that they can use those temporary tables later down the line in some other computation. So for that, views should not be used. In general, if you want to have a temporary table, there is a really nice SQL feature for that. Just say create temporary table as, and then that entire query, and that actually generates a temporary table. A view is designed to be exposed to other people in the system so that a person can actually see what it's necessary for different people. You might have different views, and they are not supposed to like use them in some other query that can use them as a temporary variable. You can if you want to, but the better way for doing that would be to just use the temporary table keyword instead. So create temporary table blah 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 as this query would actually give you a temporary table on the other hand, and then once you close that session, that temporary table goes away. And that is a better way of writing a particular query rather than actually writing a view for that particular. So when you say you're lost, do you understand that? So are you lost about views? Views are just basically a nickname for a query. You can imagine, if you can imagine that. So basically, I won't call it a function name, but essentially given a query, I would just say create view this thing. And then whenever I use a view a table, I can actually view the results from there. Okay. Now, comes to Angelina's first question before she got lost, I guess. So a view is a derived relation. So what to do if I perform an insert operation or an update operation to a view? So let's say that we had